Okay.
Your results may vary. We will be computing measures of variations for a given data set, interpreting standard deviations for a data set, making meaningful comparisons of standard deviation, and analyzing the procedure for computing standard deviation. Next slide. Next slide. How would you describe measures of variation? It simply describes the distribution of data. In other words, it describes how data is dispersed. Variance tells you how spread apart the data is, but it's an abstract number only useful in calculating the standard deviation. You can calculate the sample variance by a simple formula shown to the right. You can calculate it just as you calculate the standard deviation by following the steps that are shown below. Next slide. There's a way to calculate variance just like standard deviation. It's a simple plug-in formula. Another measure of variation is the range, the simple one I believe we all know. It's the greatest value minus the least value to give you the difference between. Here's a simple set of data. The median of the data is the 2 plus 2 divided by 2, which equals 2. It's the middle numbers of the data set shown below in the blue. The median of the lower half is called the lower quartile, quartile 1, which are the 2 numbers in red, and you add them just like you do the median and divide by 2. In this case, it equals 1, so that's quartile 1. The second half of the data is called the upper quartile, and that's how you calculate the quartile 2 median. You add the 2 middle numbers of the second half of the data, 3 and 4, and you divide them by 2 to get 3.5, and that's the median of the upper half. Next slide. 1/4 of the data lies below the quartile 1, while the other 1/4 is above. So exactly half of the data lies between the upper and lower quartiles. The data in between is known as the interquartile. The interquartile range can be easily shown here. Here we have a data set that shows the lower quartile, median, and upper quartile also in red, blue, and purple. The interquartile range is you subtracting the 29 minus the 1, which is the quartile 3 minus the quartile 1, to get the difference between the upper and lower quartiles. In this case, it's 29 minus 18, which is 11. The range is the difference between the greatest and least values, which you can also see here shown on the screen. The 31 minus 14, 17. The outlier of the data is simply the number that is either much less or much greater than the median. If it's 1.5 times the value of the interquartile range, it is an outlier. Next person.
Will be me. All right. Whenever I did this, I looked into, I wanted to use something that I'm used to, that I used every day when I was younger, and that's baseball, because we use statistics all the time. As you can see, standard deviation is the quantity calculated to indicate the extent of deviation for a group as a whole. A data set, which I'll be using two, that would be the batting average and the slugging percentage. A data set is a collection of data. Most commonly, a data set corresponds to the, what is that word right there? Contents of a single database table, or a single statistical data matrix, where every column of the table represents a particular variable. And each row corresponds to a given member of a data set in question. As you can see here, I have a sample of a standard deviation, a formula for a data set, where X is the value of each data set, X bar is the mean, and the N is the N number of values in the data set to calculate S. To do this, you have to do the following steps. Next slide, please. Next slide, thank you. To find the average of the data set, X, take each value of the data set, X, and subtract the mean from it to get X minus the X. Square each of the differences. Add up all the results from the step 3 to get the sum of the squares. Next slide, please. Then divide The sum of the squares found in step 4 by the number of the numbers in a data set minus 1. That is n minus 1. Now you have this formula. Take the square root to get S, which is a sample standard deviation. All right, next slide, please. As you can see here, this is what we used numerous times in baseball. Baseball batting average formula. In baseball, batting average, BA, is defined by the number of hits divided by at-bats. It's usually ported in 3 decimal places to read without the decimal. A player that is batting the average of .300 is batting at 300, which is good. Slugging percentage, SLG, is a measure of batting productive of a hitter. It is calculated for the total bases divided by at bases through the following formula, where AB, at bats, is the number of bats for a given player, and 1B, first base, second base, third base, and home run, are the numbers of singles, doubles, triples, and home runs, respectively. As you can see down here, the formula reference will give what I was talking about just now. Next slide. All right, here is an example of a baseball team that has, well, players of the team that, this is the all-star team, that had their baseball batting averages and slugging percentages. Like Babe Herman, he was a 516, and his slugging percentage was a 912, and it just goes on. And this is what I'll use for the 2 data sets, the batting average and the slugging percentage. Next slide. As a baseball team standard deviation for the batting average, what I did is I put all the.
Oops.
Go back. That's all right.
Sorry.
That's okay. I put down all the batting averages in a row, and then did that formula to get the standard deviation. Also, the mean is where the average for all the players is a 458. And the baseball standard deviation for the slugging percentage is 104, with the mean as a 736. This right here will give the baseball team an advantage whenever they're doing their process to put up their first batter down to the 9th batter. Reason being is you want the player with the highest batting average and the highest slugging percentage at the top, because whenever they're playing baseball, if they start off at the first inning, they're going to have more chances at bat during those 9 innings, and so they'll have a better chance of winning the game. All right, next slide.
All right, this is where I pick up. I'm also a part of Miss Amy Benzie's quantitative literacy class, and my part of this presentation is going to be talking about the interpretation and analyzation of standard deviation. And so first, I'm going to go over some need-to-know terms. The mean, which is the average of the numbers, which was explained earlier. It's calculated as a central value of a set of numbers. The variance, that's the average of the squared differences from the mean. And then the standard deviation, which is a measure of how spread out the numbers are going to be. Now, my take on this is I'm going to go through 2 different examples of standard deviation and kind of explain that to you. This first one is going to be like a population sample. I have an example. Let's say Sam has 20 rose bushes. And this is a line of the numbers of how many flowers are on each bush. First of all, step 1, we're going to have to work out the mean. I've done that here, and it's 7. And then for each number, we're going to subtract the mean from it. Here's an example of that. Let me move us over a little bit. Okay. And then it says for each value, you subtract the mean, and then you want to square the results. So as we would go down the line, we would get the results for 25, 4, 9, 25, etc. Next slide. Step 3, we want to work out the mean of those squared differences. To work out the mean, we add up all the values, and then we divide by how many. The handy sigma notation says to sum up as many terms as we want, and that's, if y'all have noticed this right here, little thing. you can write it out like this, and you start here at this value and then go to this value, or no, start at this value and then go to this value, and so forth. So we already calculated in the previous step the row of numbers, so then we just add them all up to get a total of 178. So then we're not done yet. We then divide by how many and multiply it by 1 divided by n, same as dividing by n, as in the equation here, and we'll get this, 8.9. That's the variance. Okay. Our last step is going to be to take the square root of that variance, and that gives us our standard deviation of 2.983. Okay. Now the next example of standard deviation I was going to show you is a sample standard deviation, which is only a sample of the whole population. So let's say that Sam has 20 rose bushes, but we only counted the 6 flowers, or counted the flowers on 6 of them. Okay. So the population is all 20 rose bushes. That's what we just did. And we're doing a sample of 6 bushes. So it's a little bit of a shorter list here, as you can see, and we can still estimate the standard deviation. This changes the formula slightly to this. All right. And then we'll do n minus 1 instead of n. Okay. The symbols also change to reflect that we are working on a sample instead of a whole population. All right. Let me see if I went too far. Okay, so step 1, we work out the mean like we always do. Step 2, subtract the mean and square the result. Step 3, then work out the mean of those squared differences. And step 4, we take the square root of that, and we get, of course, 3.619. Seems a lot simpler when we do a sample root, because when you're comparing the two, when you use a whole population, we got a mean 7, standard deviation 2.983. When we use the sample, we got a sample mean of 6.5 and a sample standard deviation of 3.619. It was simpler and easier and cheaper to take a sample. So that's why it's a little different from the population. And there's a nice little quote here. You don't have to eat the whole ox to know that the meat is tough. So sometimes you just need a little sample of something. This is the essential idea of sampling, to find out all the information about the population, such as mean and standard deviation. We do not need to look at all members of the population. We only need a sample. But sometimes when we take a sample, we lose some accuracy. All right. Well, here is the 2 equations for those two, the population standard deviation and the sample standard deviation. And that is our presentation. Thank you.
Sounds great.
Okay.